Hello, Rockies. Last week, I talked about the public cloud and the private cloud, the differentiations, and also the position. And this week, I'm going to talk more about the HCI and cloud infra characteristic. So what it is, no matter you are planning your private cloud or public cloud, actually you may think about the HCI cloud infrastructure or just a cloud infra approach. What are these two different difference between these two approach? So this week I'm going to share a little bit about my understanding for the HCI approach and also the cloud approach when you build your private cloud infrastructure. So to start with, here I'm talking about like a HCI infra architecture first. So when you build your HCI, your hyperconverged infrastructure architecture, first of all, you need to buy one of the HCI node. The HCI node consists of three components normally. We are talking about the computing, storage, and also maybe some security features inside the same box. After you buy the box of one of the HCI node, to start with, normally you need to buy two so that you can run your software-defined storage, some of the redundancy, make sure no single point of failure. So normally when you build your hyperconverged infrastructure, you never just install only one node. You have to build two nodes together. How we get connect, okay, these two nodes? Normally we will build another switch cluster to connect to this HCI node. You see in the top, on the top we have the gigabit Ethernet switch. In the bottom below we have the 10 gigabit switch. What are the functionality of these switches? So the top switches, the gigabit Ethernet switches, is the management switch, which can carry out all the management traffic. So when you build two nodes and work together, you must have the management switch to connect these two nodes and let them run as a one virtual single cluster. So these two nodes will talk to each other automatically and provide all the computing virtualization, storage virtualization, and also the security virtualization features. And the bottom 10 gig switch, it provides like the compute and data traffic within these two nodes. Sure, you know, when we install the application into the hyperconverged, install our operating system like Windows OS, Linux, or whatever, on top we build our application. So all this traffic need a more high performance connectivity. So normally gigabit Ethernet may not meet the requirement. So to start with, we will use the 10 gig connections. Normally, each node we have one 10 gig link per switch, and it also provides the redundancy concept. That means either link failure, either switch failure, either HCI node failure, the whole system still running smoothly without any issue. Sure, if your application and your traffic grows very high, then you may add on top two 10 gig per switch, two 10 gig link per switch. It means the total data bandwidth and also the computing traffic can allow to grow in a certain size. Of course, you can build or add more link in this kind of hyperconverged infrastructure. So this is the structure quite now most prevalent in the market, and a lot of the manufacturers, they deploy like this, and same as H3C. And when you grow, when you find your compute or storage or whatever resources not enough, it's very easy for you to add another node. Sure, when you add another node, the configuration is pretty straightforward. You need to connect to your management switch so that you can configure everything in advance and make this a newly add node become a cluster. And afterwards, when you start install application, anything in the new node, then you need to connect to the 10 gig switches to allow all the compute and data traffic to run through. So the advantage of a hyperconverged architecture is that it's growing node by node. So the overall planning and the expansion is quite easy. Then you add one more node, you connect to the management switch, you connect to the data traffic switch. So it will keep your network growing. For our solution, H3C, HCI, our single cluster, HCI node bundled together can grow to 64 nodes, okay, at one time. So this is the hyperconverged infrastructure. So you see the virtualization, the computing, the storage will be concentrated to one node, and the network will depending on the external switch to connect. So the sizing is quite simple, from 2 nodes and up to 64 nodes. After this, how about cloud infrastructure approach? How we do it? So in terms of the cloud infrastructure approach, the cloud infra architecture, first of all, everybody knows the SDN network I talked before, talking about the spine switches, the leaf switches, the network switches. So when you have a 2 spine on top, actually your network can expand easily, maybe across a different data center or locations, or you can expand your data center to different floors. You just add your leaf switches on top. And this is a very easy to grow open network. So if you need more ports, you just add the leaf switches. Sure, okay, when you plan to install your spine switches, you might have some of the empty slot, empty port, okay, for future migrations. So here is the network part. So network is totally independent of the other resources that you are going to plan. So if right now, after you have plan your network in the cloud infra, then you will think about your compute. Your compute means, okay, you have a lot of a bare metal server, like a 4 processor, 2 processor, rack server, blade server, GPU server for AI applications, some other Unix server, high density server. All are these computing resources running your applications. And if your application need more traffic to go through the network, to talk to the storage, to talk to the end user, to talk to the internet users, then you can put more link from your compute node, okay, to the leaf. All the bandwidth between the compute and the leaf switches to the network is flexible, up to your actual requirement. Sure, you do not need to build a lot of the link, because you can monitor the usage, and based on the usage, based on the network traffic requirement, then you increase the number of link between the compute and the network. And the network also need to connect to the storage. Why I put network? Because the network connect everything. So when you plan your storage resources, you need to think about like a distributed storage, IP storage, FC storage. And for a single cloud storage device, you may require it support like a block storage, object storage, file storage, hierarchical storage, different kind of storage requirement that can support your application. And sure, you may think about other backup solutions, restore or image, whatever for your application running in your compute. So all this can be supported in the storage platform. So this is the overall idea. And finally, you also think about the security resources pool. You may buy your own security gateway, physical appliance, or you build your virtual firewall or virtual resources, and combining as a security resources pool to run your firewall services, load balancing services, IPS services, WAF services within your data center. So you see in this cloud infra architecture, everything is building in block. So each block is working independently, grow independently, very flexible, and based on the customer need. And we have the network architecture to support all the connectivity. Of course, when you drill down, there are a lot of standard compliance protocol I need to understand. So a lot of the technology is right now evolving in storage. Talking about, we are right now using the NVMe or SSD to improve the IOPS, the storage capacity, the storage efficiency. So all this technology keep on changing. So, and how this related to our application, how this related to our security resources requirement, how it related to the network, right? So all different blocks can expand independently. And we are using a single cloud OS to manage everything. So this is the cloud infra approach. So when you look into this, and I make a very simple characteristic chart to let you understand more about the pros and cons. Of course, I'm not going to give anyone the answer which one is better, because all depending on your need and your actual rollout requirements. So normally, from my understanding, most of the HCI infrastructure is very good for small to medium, because we are using like a single node approach. You can increase one by one. And the one node, we put the network connectivity, the network port, the storage size, the hard disk, different kind of hard disk, together with a different kind of a CPU, multi-core CPU in one single node. So you just need to buy one node and expand the capacity, buy one node and expand the capacity. So it's very good for small to medium scale rollout. And for cloud infra, you see already, it's built up by 4 major blocks. Each block works independently. So this is the perfect architecture for large-scale cloud data center deployment. So if you are trying to run your private cloud in a very large scale, running a lot of application, whatever, so you may need to take this approach. Actually, the concept is the same, like compute, storage, security, network, and how you integrate this kind of technology into a single node or into a cloud approach. So all depending on the customer requirement, the fundamental is the same. And other characteristic, I talk about the planning. So when you see the HCI infrastructure, the architecture, right? So you can see it's very simple. It's just node by node. Then you just look into the resources and see whether you can use it or not. In the cloud infra, you need have a more like a complicated and comprehensive planning. Since we break into different blocks, each block you can plan easily, but you still need to take consideration like how many network bandwidth you need to connect, how you run the security, more like interoperability between each block you need to consider. In HCI, everything consolidated in one already. So I think this is one of the considerations that you need to think about. Sure, in the cloud infra, I'm sure all the resources you invest should have high utilization, because it just specifically look into the compute, storage, network, or whatever. But under the hyperconverged, because we try to simplify the whole deployment, so one node, compute, storage, network port, all the resources inside the node. So the utilization may not be as good as a cloud infra. Sure, in both platform, remember, I just give you the infra characteristic. I'm not talking about the software. So actually, no matter which platform you're riding, you still need a cloud OS layer to simplify all the management, because you have so many resources. No matter you're in hyperconverged or in the cloud infra, you still need the cloud OS to manage everything. And in terms of the investment, hyperconverged, of course, is much more like economical and effective. The starting investment is very small, just 2 nodes. Then you can start to build your hyperconverged and your own private cloud infra. But in a cloud infra approach, you separate the network, storage, compute, and security. That means every single block, you need to put more hardware and more investment. In hyperconverged infra, we are using the cluster concept. You have more nodes and combine together, it become a cluster. The cluster, all the shared resources, everything can be shared. In the cloud infra, it's a true distributed infra. Since we break further the compute, storage, and network into each single different block when you build your infrastructure. So one of the important note, no matter how your infrastructure can be integrated into the cloud or not, as part of the ICT infrastructure, I don't care whether it is HCI or cloud. Finally, all these resources can be centrally managed under the same cloud OS. To achieve this, the OpenStack compliance is very important. Maybe in the coming weeks, if I can get more detail, I can share with you guys more like the OpenStack integrations across different platforms, including the HCI infra, after you build your cloud infra, how they integrate together. So thank you very much. Thank you for listening this week. Bye.